I didn't realize that the machine takes the tool once it's got it. So the machine will grab the bits as it needs them then?
Yeah, so we're pretty much telling it what tool number is in there.
Oh, that's cool. What's going on, you guys? Charlie here with MAPerformance, coming to you with another episode of MAPTV. Today I'm joined by Dalen, and we're in the CNC department, and we're gonna be getting an in-depth look at what happens back here. We're gonna get the tour, and I think we're even gonna go ahead and make a torque plate. So let's jump right in. So realistically, when it came to the engine room and the fabrication, and even here in the machining area, it's three things that I honestly know very little, if anything, about. So, I mean, Dalen, why don't you go ahead and tell me, I mean, why do we have this stuff? What does it allow us to do? It looks like a lot of money, but I don't see what the value is. Personally, I don't understand.
Okay, yeah, I mean, it's kind of a simple but complex answer. For us, we started out, so when we first acquired our machines was actually when we started doing turbocharger work many years ago. Okay. So we bought the machines to actually run the compressor wheels that we made. As that evolved, and when you have a CNC machine in-house, you kind of learn that you can kind of do whatever you want. Okay. So that led to us to begin making our own flanges, making a lot of our own components to our fab side of stuff. Got it. Which then led to us making products. Yeah. So we have them for a multitude of reasons. So it allows us to do prototyping. So like now as you see like 3D printing and stuff like that kind of coming into play more, but we've gotten very efficient at cutting metal. Sure. So we're able to make prototypes very quickly. We have a lot of the tooling to do it very quickly. So it allows us to kind of have an idea into an actually workable part fairly fast. Right. These things are running, I think we're at a point now where we're 18 hours a day, somewhere around there. Sure. We're just running products right now. As that slows down, we'll kind of go back into that R&D phase and work on the development work. But right now we make products to support fabrication, so flanges, collectors, all kinds of stuff like that. We're gonna make actual products, so torque plates like we'll be cutting today. We have our catch cans and a lot of little ancillary products that we make throughout that.
Are we able to go and look around right now? Would it be a good idea to do like a tour of this area first?
Yeah. So in this area, what we'll see is we're gonna have machining centers, and then we're gonna have our engine machining stuff a little bit farther. So we have 3 machines right now in-house. We have a Mazak lathe, and we're gonna have 2 Haas machines. So we have a VF4 and a VF2. That's really just the size of the machine for the most part. Like there's more to it than that, but the size of the machines and the bigger the footprint is kind of the main difference between the two. We're able to run a lot of the same jobs. The 4 is just gonna be able to do a lot more stuff. Obviously, besides the machines, we have a lot of tooling. We have a lot of the actual programming, setup dies, old parts and pieces and stuff over the years, extra components for the stuff, so like either a prototype or something we might use as a reference piece. Okay. And then we have our Bridgeport. Anyone that's been in an older shop or any sort of machine shop recognizes this piece. This is a manual milling machine. We're gonna use this for rough cutting something or drilling precise holes or doing small mill jobs that the setup work in the CNC is just gonna take too long. Okay. This is definitely more on the fabrication and the R&D side. Obviously, we're not doing production parts on the Bridgeport because that would take a long time. Yeah. But no, this thing it doesn't get used every day, but when we do need it, it's one of the most convenient things that we can have out there. As far as the V2 and the V4, the difference for what we machine, in reality, we can machine, these are kind of interchangeable in the sense that we can machine the same parts in them. Okay. One of them just sometimes a little bit more efficient than the other on like bigger ops. So the 4 is gonna be able to do more parts at once just because it's a larger bed. Got it. So like our catch cans and stuff are almost always going to be down the 4. Okay. But sometimes we'll run them on both if we have to get a run of 100 of them through or something. You're kind of, I can see you staring, so he's doing a lot of the touch off right now. Yeah. So what this is this is basically going to get, the machine is now going to know where the material is. Okay, got it. So it's going to start to get the access of the top, the sides, correctly. But once the machine kind of zeroes where it is and knows it's, then it can start cutting. Okay. So if it doesn't know where it's at exactly, so I'm guessing right now he's centering it. Yeah. If the machine doesn't know exactly where it is in comparison with the part, it's going to chew the part up. It's going to cut it wrong. Setup work is going to be almost as important as the actual machine work, because if you don't get that right, it's just going to ruin the material you have. We've moved some stuff around, but this is a lot of like, yep, so this is going to be a lot of the tooling. So I'm not going to open up the door all the way because there is some stuff in there we don't really like to show, but
Top secret.
so it'll be labeled, it'll be a soft jaw, so it'll tell you like what it's going to connect in with, and then that would hold like a machine piece for its either second or third op usually. You can kind of see Hector doing like the post-process work, so it's not always glamorous. People think the life of a CNC operator is nothing but just unicorns and butterflies, but sometimes it's sanding holes. But so this is what goes into every single piece. So you think something as simple as a flange that you just cut it and throw it at the fabricator and it makes it. No, like he hand touches every single one, finishes every single one, and there's a lot of detail that goes in each one to make sure it's exactly what we want to be the end product to go to our customer. So this is an interesting one. This is for our Honda Catback, and this is something that a lot of stuff on the market is just a flat flange. When we started to install them, when we first made them, the factory bolts are not very long. And so the nut that we had to use wasn't engaging on it. And so a lot of the manufacturers just leave that, and you get like 2 threads and it just rips them off, or you can't really torque them. Yeah. So we took the flange we designed, and then we cut little pockets so it fits a normal size socket. So we tried like all the standard like Craftsman,
cool.
the general socket stuff.
Right.
And then there's a lot more engagement. It fits a nice flange nut, and it actually is just like a much better piece to install. So now that I've kind of rambled on a little bit about some of our flanges, earlier I mentioned to Charlie about touching off a part. So Derek is actually going to show us how he does that and what he does to kind of touch off and center that part. Like I said, it's a very crucial component to making this stuff actually work quite well. So we'll do that right now.
All right, you guys, so this is Derek. Derek's the man who's behind all the madness back here, and I'm gonna go ahead and let him explain this to me because, I mean, honestly, it's something I know literally nothing about.
Yeah, so it's honestly pretty easy. We pretty much just need to communicate to the machine where the part is in correlation to your machine zero and part zero.
Okay.
So what we're doing here is we're taking our touch probe right there, and we just need to pretty much jog it to the center of the part. Here what we're gonna do is touch off our X-axis, our Y-axis, and our Z-axis, so it knows right where it is, the height of the part, and then after this is done, we'll go ahead and touch tools off and everything from there. So pretty much what we need to do here is take our probe down, and there's different algorithms that do different options and stuff as far as touching it off. You can touch off bores, certain aspects of the part. So this one, we're just gonna probe the center of the part and the top of it.
I'm really glad we've got someone who knows a lot more about this than me to make this happen, because I would screw this up.
Yeah, and so pretty much after we do this, we take all our tools for the job, and then there's a secondary probe over here on the corner of the table.
All right.
We'll actually load the tools in and then just give it a rough height dimension and what tool number it is.
Okay.
And then we pretty much just run that. It's the same sequence as doing that, but in a tool. And then after that, we load our programs and let it rip. So we have 6 tools that we need to load into this, and you know, the different tools do different things. We have pretty much something like this here is a face mill. That's generally going to give you, you know, your flat, smooth surfaces, anything you want to be flat over a long distance. Then here's our various drills and end mills. This is the drill to clear for the head bolt holes on our torque plates.
Okay.
And you know, this is to rough the bores out. So, you know, depending on what bore size the application is, what we make the torque plate for.
Yep.
You know, we use this and whatnot. But yeah, that's pretty much it, is regards to setting up a, you know, a simple daily job.
Seems simple to you. All right, cool, man. Well, I'll let you do your thing, and maybe we'll check back in when it gets running and whatnot.
All right, sounds good.
Cool, man. Thanks.
Yep.
So will you have to do touch points for these as well once you
so
load them back in, since they're not like exactly the same?
Usually we do it, and then we'll set up kind of like a mechanical stop.
Okay.
So it'll be, you know, say it's hanging off one of the devices this much, we'll set this up, and since they're cut the same length, we'll just go and just bump it up because it ends up taking a 1/4 inch off each side.
Sure. Insert light bulb here.
All right, so now all our tools are touched off. I mean, we're good to go on this program here. So usually when we run stuff, we'll do it tool by tool and
Yeah.
just kind of see, make sure the program runs good, make sure everything looks good.
Right.
If there's any changes that need to be made, we'll do it on the first part. So
Absolutely.
obviously you don't mess a bunch
Makes
up
sense.
after that. So I guess we'll see you guys when I'm done.
Yeah. So someone's got to tell it to do all of those little things?
So I can,
Wow.
I mean, I can give it a, like the job it's doing right now, how it's doing the
Look
sport.
at this. You can't, no one can make sense of that.
Well, they can. I mean,
Oh,
but
I-
not just like that.
This
So
is
what
like
that's
entering the
doing-
Matrix.
So that's just roughing out the bore of, you know, the torque plate where the piston would go through.
Okay.
And where all that code comes from. So pretty much all this yellow you see here is that code. So
Okay.
everything that's going down, it's telling it how deep to go down per cut, how far to go out per cut.
Hey, have you ever seen like any of those new food shows on Netflix where they use the like really dramatic like classical music intro? What there's like an actual that's like an actual song that anybody could use. You should totally play that music as this part's being machined. All right, you guys, so that's gonna wrap it up for today's video. We got the full tour back here. We made the torque plate. We got to see some of how this machine works on the inside and all of that. If you guys are interested in any of the MAPerformance in-house products, chances are something from this department was used to make them. If you guys are interested in any of that stuff, check the link in the description. That'll take you to our in-house performance parts that we make. Otherwise, thanks again for tuning in. This is what you can expect next week.
I would say that the fitment between these two has been better than the fitment with the red car. Like it's been consistent between the two if you just made it wider by a little bit.